Hello, we are Little Endion Entertainment. Our project is Drago's Inferno, and the presenters today are myself, Mike Enriquez, Elizabeth Collins, Brian Tanner, Scott Hodge, and Ryan Alon. Today's presentation overview, I'm going to start off with a project introduction, team member introduction and roles, and an overview of the project. And Elizabeth will do a project problem statement and a requirements overview. Brian Tanner will do the encountered problems and solutions. He will give a design overview and a game demo. Scott Hodge will also be doing a game demo, and Ryan will finish up with the project wrap up and any future game enhancements. So the team members, Elizabeth Collins was our project lead and a sprite designer. Scott Hodge was the system designer and lead developer. Brian Tanner was our system admin and also helped develop. Ryan was our graphic designer and responsible for the game animation. And I came up with the game concept, documented all the requirements in the SRS, and produced the project test plans and procedures. Our project overview, we designed a two-dimensional desktop computer game where the main character is a dragon named Drago. The game is written in Java and includes all original artwork. We've included some graphics and game animation. We also included sound effects, but we didn't come up with the sound effects on our own. They are kind of from a package that we could use with Java. Project overview continued. Drago's Inferno follows Drago's quest to find and retrieve stolen dragon eggs. In order to retrieve the eggs and complete the quest, the player will have to navigate the entire game map, defeat a variety of enemies through a series of attacks, and manage to maintain a health level above 0. In other words, he has to stay alive.
Our motivation for this project is to appeal to the older gamer crowd who have a nostalgic link to classic computer and video games such as Zelda and other type of medieval style games. The key interest points of our game is that it's a medieval classic style 2D adventure game, and we have a role reversal where our hero is the dragon, and they're fighting against the humans who are the bad guys. We believe that the popularity of medieval themed items, games, and movies and TV shows will help with the sale of our game. Our functional requirements for this game are the basics of most gaming systems: being able to install and update programs, start, pause, and exit the game, being able to see the character and objects on the screen, using the keyboard for input. We want the user to be able to launch and defend attacks as well as the enemies the same way. We need our enemies to be able to find the player in the playfield, and that our player has a number of different attacks and things that they can do on the playfield, and also that the collision detection works properly, that they're not going to walk through walls or obstacles or bump into each other or stand on top of each other, things like that. Our non-functional requirements include the response times of collision detection and a star search response, as well as the player being able to respond to the user's input on the keyboard in a relatively fast manner. We also want to make sure that the playfield is displaying things correctly, the viewing angles are correct, and that things aren't on top of each other in the wrong order on the playfield. Due to our time and resource constraints, we were unable to incorporate some of the requirements that we wanted our game to have, and those are basically extra features for the player, extra abilities, the ability to view game stats and save and restart a game. We want to add in some extra levels and make the health requirements for the player and the enemy so that they don't die immediately with one attack. Also, we have some NPCs we want to incorporate when eggs get rescued, that they turn into dragons that can assist the player and fight off the enemies.
Hey, I'm Brian Tanner, and I'm going to be discussing some of the problems we encountered with programming in the game, some of the problems we encountered with the project in general, how we overcame these problems, and give a small overview of game design and focus, followed by a high-level demonstration of the subjects talked about here in the game. Some of the problems encountered with Java include learning Java's graphical libraries, which primarily include JSwing and AWT. These are the two most common graphical libraries used when developing GUI applications with Java. And learning Java's resource management, or referencing dependency files such as data files and images. For example, the scanner class isn't very suitable for accessing files inside of the package, as the class loader was specifically developed for that purpose. Some of the problems encountered with the project in general include a lack of experience with game development amongst the members of our group, and the sheer complexity of game development in general. All in all, we ended up with 32 unique classes and interfaces, 260 images for sprites, textures, projectiles, and other items, and 7,329 lines of code to date, along with other little miscellaneous items. The best way we found to overcome problems with Java was to look to multiple outside sources, including several books, such as Developing Games in Java and Killer Game Programming. And Java also provides excellent documentation on their website at oracle.com. Several of us have also had Java courses in school, which helped. And of course, Google always comes through in the crunch. We dealt with overcoming problems in the project by planning early on. Some of the points we decided to stress were team communication with weekly meetings, job delegation based on strengths. In the beginning, each member's strengths were assessed and put to good use throughout the project. We developed a strict schedule to adhere to. That was also established in the beginning of our project. And the complexity of the project allowed modules to be developed independently of each other initially. I'd like to give an overview of design by contrasting how our game differs from other similar game projects by first looking at the graphical components in general. In a traditional game grid, 32 by 32 squares or 64 by 64 squares, usually powers of 2 squares, comprise the game grid, where images are placed, sprites, characters, and such. In Drago's Inferno, we use 32 by 32 squares, but we cut them in half, giving us much more control of the game grid. Some sample sprites are included below. We divided our map area into partitions, commonly referred to as binary space partitions. This divides the level into convex regions of space. It is used to determine the location of entities on the map, where each area is a leaf in the BSP tree. The partition lines determine what area is traversable. The lines determine what areas are walls and what areas are paths that the character can traverse. It is also used by the AI to lead enemy characters to Drago in the A-star algorithm. Collision detection is another important aspect in game development. If it weren't for collision detection, then characters would just walk over walls and wouldn't be able to interact with each other or other objects on the map. It provides boundaries such as walls and provides a reaction when those boundaries are reached. Hitting a wall at an angle, for example, slides you along the wall versus stopping you abruptly. It provides interaction with objects such as picking up items, hitting enemies, or being hit by projectiles. And ours specifically is managed by a collision response table that contains results to happen when two types of objects collide, as we'll see in the next slide. And here is a small sample of the collision response table. Given the collider and collidee, we can pull from this table and see what results should happen from that collision. And here we'll have a small demonstration of Drago's Inferno, mainly covering the topics just discussed. The first thing we'll look at is the collision detection algorithm at work, which when Drago runs into a wall at a 90-degree angle, his momentum comes to a complete stop, while we can tell he's still trying to walk with his movement. And then if Drago actually contacts a wall at a 45-degree angle, his movement is slowed down, but it isn't stopped as it would be with a head-on collision. If we look at the partition lines, we can easily see here how the map is divided into multiple areas, the yellow lines representing the partition lines that are either a wall or a traversable portal. We can also see here how the 32 by 32-bit squares help render the map. See the square tiles on the floor, which are actually two triangle halves pieced together. And we can see that the triangles actually make it easier to work with angles in the map and letting Drago move in 45-degree angles versus lateral and up and down movements only. It's also important to note that the rendering of the objects in the game play an important role in the order they're rendered. Drago appears on top of the floor, however, he's beneath the walls, allowing a three-layered effect here, which is the appropriate effect. We don't want Drago walking on top of walls. Here's another great example of collision detection at work with the fireballs. So when the fireball makes contact with the enemy, the collision detection table actually tells us that the enemy should be destroyed and a resulting explosion should happen. Collision detection is also used to pick up items throughout the game. And the resulting sound effects, each action in the game has a resulting sound effect. And here we see Drago testing the boundaries again, making sure he can't get outside of those lines, because Drago himself is enclosed inside of a boundary, so it's important that there's no cracks or he can't fall through in a glitch state. And that concludes the demonstration. Thank you.
My name's Scott Hogue. This is a demonstration of the game Drago's Inferno, and this here is a working prototype level which we coded by hand. I originally insisted that we make a level editor, but due to time constraints, I thought it would be easier in the end to go with an example level and see how much we could put in the game. I think it turned out pretty good. There's a small amount of shearing, as you can see, but once we put in a buffer strategy, that should be eliminated. Here we see a giant horde of archers moving according to the A-star algorithm. Right now they're not capable of shooting arrows, but they should be easy to put in once we have suitable sprites. One feature we added that I was really proud of is that if you burn down a path through a forest, the enemies will actually chase you down the burnt path. I think this will provide for a sense of realism. We've added items to the game in the form of 4 eggs, but they currently add no bonus stats to the player. To get the enemies to move intelligently, we used a portal system generated from polygons. In test mode, we can turn on all these structures and allow them to be viewed as an overlay. Here we see that every wall is bounded by a polygon. The polygons are then used to generate a binary space partition shown here in yellow. The binary space partition then becomes the basis of the portal system, which enemies use to navigate in search of the player. Here in the forest, you can see that some portals are red and others are blue. The ones that are red are closed to the enemy search algorithm and treated as if they weren't there. Every time you shoot a tree, The portals open up and are thenceforth explorable via A-star search. This is what allows enemies to chase the player down the burnt path. One more thing I wanted to show was that if you increase Drago's speed in test mode, you can cause him to walk faster. The collision handling algorithm we implemented took a very long time to design, but is so precise that objects can move at arbitrarily high speeds with perfect sliding and no errors. So for example, let's set Drago's speed to around 200. Drago can now travel at warp speed using an algorithm that projects him as far as possible around walls during a single frame. Again, I am Scott Hogue, and this completes my demonstration.
Hello, my name is Ryan Elaine, and I'm going to talk about the conclusions that we came to and future work recommendations. So what I want to discuss first is, how long did it take us? How much did we get done? And later I will mention what is left. And finally, what the overall cost was. First up, time. The project took place over 96 days. Of course, with other classes, not all that time was dedicated to the project. In that time, we had 8 assignments used for the final product and 13 meetings. I will discuss in a second how these numbers affected the potential cost of this project. So what exactly did we get done? What you may have gathered from the demonstration, the full functionality of the enemies and the dragon are not yet implemented, partly because of the lack of animations that we've prepared. Now we have the cost. The following chart shows what the cost would be per person in our group using a $37.50 per hour pay rate. As we mentioned earlier, with a total of 13 meetings, each person would cost about $250. Since each person did 8 assignments, that would have the cost almost $500. Finally, the individual work put in, for instance, Elizabeth and I were drawing and rendering sprites, or Scott and Brian coding the software that wasn't covered by Assignment 6. It came down to an average of each person spending about 30 minutes a day over the 96-day period for a total of $1,800 per person. So in grand total, our entire team doing this would have cost almost $13,000. And also, you'll see that there are no miscellaneous costs because we used a free graphics engine that was provided natively by Java, and we were also using freeware for our photo rendering for our sprites. So would I recommend continuing this project? Yes. Since there are no miscellaneous costs, such as the advanced graphics libraries or photo rendering software, this project can be built upon with just a little bit more time. There were a lot of features that we could not implement, such as the missing sprites and their functionality, so the software does have room for improvement.